So I start my lab tour with the personal protective equipment section. Here I have some nitrile glove box. I also have some latex glove and an acid resistant rubber glove. And this is a long drawer in which we have personal protective equipment like this is a mask, respirator mask, and other personal protective equipments are inside this drawer. Inside this drawer you can see a bag, and this is the bag of that respirator mask. Behind that you can see a pair of goggles. One of them is covering the entire eye. You can also see a packet of alligator clips here, and I also have a red marker pen. Okay, let me just keep everything back into the drawer and let us close that one. Moving on to the next box, the drawer just below that, it contains the digital balance, rubber corks, spatulas, tweezers and test tube holders. Let me just open the drawer, and inside that you can see the digital balance here. It is packed in its own packaging. And let me just keep that aside and show you the rest of the contents in this drawer. And behind that is a cardboard box which contains rubber corks of various size. And I have a pair of scissors. One of them is missing right now. I don't know where it is. Again, more corks. And behind that is a blue colored box which contains all the stainless steel instruments. Oh, there is the second pair of scissors. Let me just open up the box for you, and inside you can see all sorts of test tube holders and spatulas. Okay, so that's all in the second drawer. I'll just show you the digital balance. Let me take that out for you. This is the digital balance. I'll just take it out of the plastic case. It's very difficult for me to just use one hand to take it out because I'm holding the camera in the other hand. Okay, this digital balance can weigh up to 1 kilogram and has 2 decimal places, which is actually pretty accurate for most of the lab work. Now moving on to the third drawer, and inside this drawer we have the chemical inventory. The chemical inventory is actually 2 telephone index. I am using this telephone index book for writing down the inventory, that is the list of all the chemicals present in my lab. This telephone index is a special type of book in which you can scroll up and down the knob to the desired alphabet. This one is particularly for organic chemicals. Just scroll down the knob to the letter which you want and click on the button below, and you can see the letter, the page for that particular letter, and the chemicals will be written in that. For example, here I am choosing P and Q, and you can see all of the chemicals, organic chemicals, starting with the letter P. The same thing goes in the second book, which is for inorganic chemicals. The other things present in this drawer is a UV light, UV torch, which I have used in some of my previous videos, and some aluminium foil and a pen. Moving down to the last drawer, it is actually unlabeled. It contains some miscellaneous stuff like this heating mantle coil, which I have used in numerous of my previous videos, some tissue paper, and again some rubber tubing. Next we move on to the workstation. Workstation is actually just 3 feet into 3 feet size. On the extreme left side of the workstation I have my hot plate stirrer, which I have already shown in one of my previous videos. I actually set up this workstation like 6 months back, and back then it was pure white, and now it has turned all this brown to black color discolorations due to the stains. Here I have a picture of the periodic table, and on the extreme right side we have some of the chemicals that I was using just now. There is a Gibbs apparatus in the back and an old Bunsen burner, a bottle of acetone, a wash bottle, some reagent bottles, and an Erlenmeyer flask. The floor and the background behind is vinyl coated, and on the left side you can see a Gorilla Pod, a tripod stand for taking videos. Now for the glassware. Most of the glassware is stored in this big container. Starting from the top left side, we have some platinum wire over there, which I use for doing the flame test. And this is a 250 milliliter 3-neck round bottom flask with an adapter to adjust the size to fit to the standard setting. Here are some Erlenmeyer flask, flat bottom flasks, and some funnel. Here is another 250 milliliter 3-neck round bottom. Here are two 250 milliliter separatory funnel, and inside this box we have a very small graduated cylinder, a 10 milliliter graduated cylinder, which I have used in numerous videos previously. I also have the 50 milliliter graduated cylinder, actually 4 of them, which are all actually looking the same. I also have a plastic graduated cylinder just sitting in front of that, and this one is a 100 milliliter graduated cylinder. Now moving on to the flasks. Here are some round bottom flasks, and this one is actually pretty much stained with the previous experiment. Both of these are 100 milliliter round bottom flasks, and this one is a 50 milliliter round bottom flask. And I also have a 100 milliliter 3-neck round bottom flask, and it's actually having this red color due to the rubber from the clamp. And this is actually interesting, a very small round bottom flask that is a 25 milliliter round bottom flask, and even smaller 10 milliliter round bottom flask. I also have a 250 milliliter round bottom flask and a 500 milliliter one, which I have cleaned and it is kept for drying. And here is a pear shaped flask. I have 2 of them, 100 milliliter each. And these are some glass toppers. And here I have some watch glass and a petri dish, as you can see. And in here we have a thermometer adapter and again a glass topper. Now in this cardboard box I have the condensers and columns. I'll just open it out for you guys, and I have completely covered the equipments in bubble wrap because these are all actually expensive and can easily break. Here is a vigorous column which I use for fractional distillation, and this one is a pressure equalizing addition funnel which is very helpful in organic synthesis. I also have a Liebig condenser which is out for drying after one of my previous experiments. And I also have an air condenser, which is also a type of condenser where there is no water running but it cools down with the air current. Now for one last piece of storage of glassware. Here are all the beakers, and I have a lot of 250 milliliter beaker. This one is a 250 milliliter beaker. I actually have 1, 2, 3, 4 and 5 250 milliliter beaker, and this one is actually a 500 milliliter beaker. And behind we have a very big 2 liter beaker, and this one is a crystallizing dish. Over here I have the smaller beakers, a 100 milliliter beaker and a mini 50 milliliter ones. Now let us move on to the chemicals. I have stored the chemicals according to this storage pattern separately for organic and inorganic chemicals. This was adopted from the website of Flint Scientific. You can download the free PDF from them, and this is actually a pretty good way of storing the chemicals, and this will keep out the incompatible chemicals away from each other. Okay, let us move on with this. Keeping this in mind, starting with the inorganic chemicals, number one is the metals and hydrides. You have to keep them away from water. You can see all of my metals are stored here. You can see some iron filings, copper metal, zinc, manganese, lead, tin, chromium metal behind, aluminium, sodium metal here. Behind there is some magnesium metal turnings on the top left, and behind the zinc metal dust I have a glass bottle containing more sodium. That is the magnesium ribbon just pointed out. And here is the tin metal granules, and behind that is the tin metal powder. Now moving on to the inorganic section 2. And section 2 is quite a big one, as it has a lot of chemicals, the halides, sulfates, sulfides, thiosulfates, phosphates, halogens, acetates, etc. And this is actually a mess. A lot of chemicals stored on top of each other. Here is some potassium chloride, sodium nitrite. Behind I have some sodium tungstate and potassium iodide. Then over there I have some nickel 2 chloride. That's the nickel 2 chloride, tin 4 iodide, some iodine, some tin chloride, that is tannous chloride. Then these smaller bottles are actually the ones which I prepared myself. These are actually small 50 milliliter sample bottles which I purchased at a very cheap price, and these are actually pretty airtight and can hold these solid chemicals pretty well, and they also look so cool. Actually, this is the section which contains the most of the inorganic chemicals. Behind there is a bottle of zinc chloride and aluminium chloride, both of which are anhydrous. Coming down below we have the remaining section 2 chemicals, including sodium thiosulfate, potassium chloride, copper 2 acetate, sodium sulfite, sodium bromide. Okay, moving on to the number 3. Number 3 includes amides, nitrites, nitrates, azides. I know I have stored the sodium nitrite in the section 2. I should have kept it here. Okay, moving on. Here are the nitrates. I have stored the ammonium nitrate here itself because I only have less than 1 or 2 grams of ammonium nitrate only, which is safe actually. There is some thorium nitrate which I have not opened yet, some cobalt nitrate, potassium nitrate, bismuth nitrate, barium nitrate, sodium nitrate, and all of the nitrates are here. Okay, moving on to the inorganic number 4. Number 4 is hydroxides, oxides, silicates, carbonates, and carbon. And this is also a flooded set of chemicals. As you can see, there is barium hydroxide, sodium carbonate, potassium hydroxide, manganese 4 oxide, sodium bicarbonate, lithium carbonate, more sodium hydroxide in the back, basic copper carbonate, cobalt carbonate over there, some sodium hydroxide solution at the back, and behind the lithium carbonate we have some potassium carbonate, and behind that is this big box of lye. And behind the sodium bicarbonate I have some strontium carbonate, and behind this calcium hydroxide some ammonium carbonate, and nothing behind that. Inorganic 6 contains some potassium chlorate, some sodium hypochlorite 10%, and a 30% hydrogen peroxide. The inorganic 7 contains some arsenates, cyanates, and cyanides. Of course I don't have any cyanides here, but I do have some cyanates, which are some potassium ferrocyanide. That is the potassium ferrocyanide, and the ammonium thiocyanate, some sodium hexacyanoferrate, and some mercuric tetrathiocyanatocobaltate. That is actually a blue colored complex, and I have done a preparation video. If you want, you can just check that out. Now moving to the inorganic 8, before that in this section I have some of the equipments which I forgot to show. These are actually 2 evaporating or the china dish, and this is actually a crucible, some aluminium foil, and here is the steering magnetic beads, some filter paper over here. Okay, now moving on to the inorganic section 8, which contains some interesting compounds. Over here I have some vanadium pentoxide, potassium chromate, some vanadilyl sulfate, which I prepared in one of my previous videos, some vanadium pentoxide again, which looks actually black, I don't know why. Then there is some potassium dichromate, then that is some ammonium tetrathiomolybdate. That was actually a pretty beautiful ruby red colored crystals. I have done a preparation video in my, you can check that out in my playlist. And behind that is some ammonium metavanadate and some potassium chromate, and that is some sodium ammonium dichromate, some potassium metabisulfite, some potassium permanganate over there, and behind that I think that is ammonium molybdate and some borax behind. That finishes off the inorganic list, I think. Oh wait, the last one is the inorganic 10, which includes the sulfides and phosphorus, etc. Here is some sodium sulfide, phosphorus pentoxide, and this unlabeled one is actually the sulfur powder, some iron sulfide, and some 25 grams of red phosphorus. Okay, now moving on to the organic section. Number 1 in organic section includes the organic acids, and there are a lot of organic acids. Most of them I prepared myself, like the citric acid over the adipic acid, hippuric acid, benzoic acid, tartaric acid, 3-nitrophthalic acid, and tranilic acid, phthalic anhydride. And here are some interesting compounds like the creatinine hydrochloride I purchased for making some complexes with creatinine. That is the niacin. I have made pyridine from niacin in one of my videos, upcoming videos. Some picric acid, sulfanilic acid, oxalic acid here, salicylic acid in the back, phthalic acid and phthalic anhydride. Okay, moving on to the organic section number 2. It contains ethylene diamine and some of the this is also a packed cabinet, and I have kept the bottles on top of each other, just don't mind that. These are all interesting compounds like para-nitroaniline, para-iodonitrobenzene, and actually on the left side is the organic number 3, which includes the aldehydes. Actually I have kept the 2 and 3 together. Here is some 3-nitroaniline or meta-nitroaniline. All of these compounds which I prepared myself, I have separate videos on the preparation of these compounds. You can check the corresponding playlist, you can find those videos. This is some thalamide, that is some 4-iodo-nitrobenzene. The video will be coming soon. This is some of the thiamine which I used for preparation of benzoin. That was an interesting preparation actually, the preparation of benzoin without using a cyanide salt. There you have some orthophenylene diamine, aniline behind that, and N and dimethyl aniline at the extreme back behind the aniline. Now moving on, here I have some urea and thiourea, and there is some hydroxyl ammonium chloride, and behind that is some diphenylamine, and in this small bottle we have some methenamine. Then here is some paratoluidine, some formaldehyde, and some benzaldehyde. Let me turn that. Yeah, that is benzaldehyde. Okay, moving on to the next cabinet. Here you can see just 2 bottles of ammonia actually placed here. Below that is the organic number 4, which contains ketones mainly, and the chlorides, the thionyl chloride, cyclohexanone, benzoyl chloride. All these are placed in the back. This is some benzophenone, chloroform, and that's acetyl chloride. And the smaller bottles contain benzoin, benzyl, dibenzyl acetone, etc. Now we have the organic 8. Organic 8 contains the phenols and cresols. As you can see, there is glycerol, resorcinol, beta-naphthol or the 2-naphthol, and some thymol over there, and that's some alpha-naphthol solution behind, and behind that there is some hydroquinone, and that glass bottle is phenol. Now moving on to the next section. The next section is the organic 9, which contains all the dyes, stains and indicators like the universal indicator paper, the litmus paper, the phenolphthalein solution, methylene blue behind that. Then this is some universal indicator solution, the Leishman stain, the safranin stain, bromocresol green, litmus blue solution. This one is the methyl orange solution, chlorophenol red indicator, and some of the indicators and dyes which I made like the ammonium manganese pyrophosphate. I had done a video on that, and underneath that is the methyl orange. This is also synthesized in one of my previous videos. And down below we have some miscellaneous chemicals which I could not place in their actual place due to lack of space, like some cyclohexanone oxime, some 1,3-dinitrobenzene, diphenyl quinoxaline, and that is some aspirin. Actually that bottle is empty right now. Some anthracene, some phenyl hydrazine hydrochloride, and some dimethyl glyoxime. There's some cream of tartar, that is potassium bitartrate. Now inside the door of the cabinet we have this beautiful 100 milliliter reagent bottle. All of these are actually empty right now. I can store the organic chemicals in that. Here I have some vegetable oil for making an oil bath. Now inside this one in the door we have 2 amber colored reagent bottles, one containing silver nitrate solution and another one is pyridine, and this preparation will be coming on upcoming video on the synthesis of pyridine from niacin. And here are some clamps, Below that is some reagent bottles containing all the 3 mineral acids. Actually, I have the larger acid cabinet in which I have the larger bottle of acids. This one is for convenience, so that I don't have to go and open those big bottles of acid and risk myself. Again, some 100 milliliter reagent bottles which are empty. Moving on to the lowermost part of the cabinet, we have the miscellaneous inorganic stuff like the copper 2 sulfate, calcium chloride, that is anhydrous calcium chloride used as desiccant, some activated charcoal, sodium potassium tartrate, and some copper 2 citrate that actually has some blue color, beautiful blue color to it. That is some sand, and that is some 3% hydrogen peroxide, some Devadas alloy powder. It's actually a very good compound. I am planning to use that in one of the upcoming synthesis. And in this big cardboard box I have amber colored dropper bottles containing some reagents for qualitative analysis like this Felling solution A and B, some silver nitrate solution, that one is citric ammonium nitrate used in qualitative organic analysis, and this is also used in qualitative organic analysis, that is 2,4-dinitrophenylhydrazine. Okay, moving on to the cool stuff, that is the flammable section. In the flammable section, let me just open it up for you, and these are all the compounds stored here. And I have some, that is some benzene, acetone, isopropyl alcohol, diethyl ether, some wood polish which contains toluene, some butyl alcohol, tertiary butyl alcohol, cyclohexanol, ethanol, and methyl ethyl ketone. So that is one of the flammable section. Just to the left of that I have another bottle containing redistilled solvents. All the solvents after use I will just distill them so that I can reuse. Here is some used ethanol which is purified by distillation. That is a 2-liter reagent bottle, and these are other reagent bottles for storing acetone and dichloromethane. Now moving on to the acids cabinet. The acids are labeled under inorganic number 9. Let me just open up for you. And the acids cabinet actually contains all those mineral acids, and apart from all those mineral acids, the other acids that I have in here are the, let me just take it out for you. And this is some formic acid, and that is the sulfuric acid. Oh, I can't take it out with just one hand. Anyway, here is a hydrochloric acid. There is also some nitric acid somewhere. That is some hydrobromic acid, an interesting acid. Some orthophosphoric acid, which is 88% concentrated. And this is some chromium trioxide, the chromic acid. Moving on to the poison section. In the poison section, I'm actually not telling the name of any of them. You can just see what is inside. Above that we have some thermometers and a hygrometer. That is the hygrometer. More thermometers over here. Now this box contains a lot of glass bottles, and in each of those glass bottles they are for storing separate waste. I have separate bottles for acetone, ethanol and dichloromethane so that it will be easier to just redistill those solvents. So yeah, that's all in this lab. That completes the lab tour video. Many of you people were thinking that I was having some kind of professional lab setup, but actually my workspace is very confined and small. Only advantage that I have is the personal protective equipments that I have and a lot of ventilation, so I don't have to deal with poisonous gases. So I just have to tell you guys is that be very cautious while handling these chemicals, and if you don't have the necessary PPE or ventilation, don't ever try doing this at all. So if you enjoyed this video, do subscribe to the channel, and if you can donate via Patreon or PayPal, the links are provided in the description. Thank you.